All right, cool. So this is a brief explanation of how grip works and all of the ins and outs of it. So the first thing that I should do is I am going to share my screen. That, yeah, okay. So this is this is grip building and running. Have you seen it? Usually doesn't take this long, but they actually no, it's built. I just switched branches, so this is why it's taking this long. So the basic UI is the idea behind it is that it's a graphical program for doing computer vision. So the idea is I can create a webcam, add webcam. I can preview that. I can resize it because my face is huge, and my webcam can't. It just creates a huge image. Well, my hair looks like that. Okay, so this is basic operation. Webcam is the source. It's feeding into a resize operation. This is calling OpenCV core code under the hood, and this is all Java. So it's OpenCV in C wrapped with a Java library. So then I can do something like I want to do an HSV threshold. I want to plug this into that. I want to, let's say, threshold off. This is bright orange, and that'll stand out well. So if I say I want to grab this bright orange thing, I can do this. And hopefully I can get the bright orange thing to stand out alone. There we go. Now I can do things like blur that, so I can throw this down and blur these operations. So I want to do this first, and then I want to do this. So I want to see what it's doing. So I want to blur it so that like kind of all the orange kind of merges together, so I get that like continuous blob, and that gives me that continuous blob there, right? 0.3. 0.3. So that gives me that giant blob there. Now I can do something like I can do a contours, so I can find the contours of that, and that will find the contours of that image. And then if I want to publish those, I can go over to network, and if I was running ROS, I could publish to ROS. My computer's not running ROS, but you can publish to network tables. I don't have network tables enabled, and somebody else is working on an HTTP server that will publish JSON data. So you can just get it as a simple HTTP request. You can view it in the web browser, which is really convenient too. So that's the basic rundown of grip. You can add additional sources. We have image sources. We have IP. So you can support an IP camera. So you can go out to the web and find an IP camera. You can also, there's different settings. So that's large. So you can deploy this. So grip runs on a personal computer, but it can also run on a Rebel Rio, which I can't see. No, that's attached to a robot. Anyway, so it can run on a Rebel Rio, and that's Rebel Rio is a Linux ARM chip, so it has SSH capability. So what we do is we take the core UI of grip. We take the core library of grip that doesn't include the UI and SCP that over to the robot, and that can run headless. That can run headless. So what's really cool about that is that you can do, for FRC, you don't need to do the computing on another device, which then causes a lot of traffic across the wireless network, which can be bad for robots if you're trying to drive really fast and if there's a ton of packet data getting sent back and forth. So group you can deploy, you can set the deploy address, you can set where the JRE is located and JVM args. Network tables address if you have network tables running on your local machine versus if you have it on the Rio. And then also team number for if you want to just set all of them instantaneously. So that's this user settings. Did I just lock up grip? We know a bug. So you could kill that. Yeah, deadlock. I do have a warning about that. So there it is. I know where it's deadlocked. I don't know why it's deadlocked there, but it's deadlocked there. So that's good to know. What I want. Also not what I want. He's not in the state. Brad's not here. Oh, cool. Thanks. Okay. Everybody's always looking for Brad, hence why. Yeah. So this is running again. So the other thing you can do is you can deploy. So you can save your projects, you can load them. That's the other thing is that like this project, you either need to bump major versions. So we're on version 1. But if you want to bump major version, if you're gonna break saves, we have a test in there that like makes sure that like old saves work. But like if you want to break compatibility, that's a major version bump. So you have to like because otherwise people won't be happy when they can't open their old saves in new versions of grip. So that's something we're always dealing with. This is the deploy UI. So if you want to deploy, you have the same settings you have in the project settings, but you can do things. And then also this is a live streaming window of the console output of that thing. So it'll give you basically every logger statement that we have in grip is enabled in this in the headless mode. So you'll get everything, which is helpful and can also be a huge amount of data to look through. And it also, you can set the project file so you can deploy to a specific project file name so that like, because people want to launch grip within their FRC user program, so doing it within Java. So some people want to launch different grip files based upon like whether they're red or blue. That's how that works. Also stop and deploy and that. Okay, and let's see. So code. This is actually in the process of getting reworked, but the basic underlying functionality is this operation class. So this operation class is this is, so each one of those steps, let me just have grip running again.
Like blur and the resize stuff?
Yeah, so there's 2 layers of that to that. Why is my terminal not showing up? It is there, just really small. So grip is still running. So these are what we call steps. Each one of these things is called a step. These are called sources. So this is where camera sources come from. This is where data comes from. These either use or consume them. We at one point had this idea of a type called, or of another thing called a sink, which would be what gets sunk to, but those ended up just turning into operations. Like that's what you publish network tables values with, or ROS values with. And then there's this idea of connections. So these are connections. This is a socket. So each one of these things is a socket. This whole thing is a pipeline. So all sources, steps, and connections are contained within the pipeline. And then there's a pipeline runner, and so we have different threads running. We have one thread that runs over here in the webcam, and this spits out images. Every time there's a new image from the webcam just puts it in its basically in an inner variable, and says, hey, I've got new data. And that just constantly gets new images and says, hey, I've got new data, hey, I've got new data, hey, I've got new data. There's the UI thread, which at one point ran the entire pipeline. So at one point when you like slid any of these sliders, that would call, like whenever you did this, you would be calling native code. Like it would be running all the way down and running the rest of the things, which would be ridiculously slow when you had an operation like bilateral filter is incredibly slow. Yeah, I don't want to turn it up that high. So basically, like this slider, basically the whole UI would hang out because like you'd be running native code and that would all. So this might actually not even compute. It's a huge image, and it takes forever on a small image. But that was a problem. So there's a third thread behind the scenes that's gonna have to wait for the other thread to finish before it'll be able to remove it. Might have. We'll see if that happens. So anyways, and then there's a third thread running behind the scenes that runs the entire pipeline. So the sources are throwing out saying, I've got new image, I've got new image, I've got new image. The pipeline says, hey, you've got a new image, great, I'm gonna run everything from left to right. So it is what runs there we go. So it is what runs all of these things. And the UI thread, we try to keep the UI thread just doing UI things, and it also does the rendering of the when I'm doing these previews, it's also doing this rendering of this preview. So that's our threading model. So back to so currently this is what we have, and we're trying to get rid of this. We're trying to figure out how to do this differently. But so I have 3 steps. So each one of these things are represented as a step object. But I have 2 operations. So I only have 3 operations. So an operation is a singleton in a sense that there's only one per running instance of grip. We don't have singletons in the traditional sense anywhere because singletons are bad practice. So we use dependency injection to get these objects in the locations that they need to be in. So this is a blur operation. This is a resize image operation. This is a mask operation. But this blur step and this blur step and this blur step, they both point to the same object, the same blur object. So what happens is that there is this method called perform, and we're hoping to change this so that there is separate instances of operation per step, because that'll make it easier for them to write, them, because currently, well, I'll show you. So perform is there's 2 versions of perform. One takes input sockets and output sockets and data, and one just takes input sockets and output sockets. And that just lets you like choose which one you want. This one came first, and then we realized we needed to pass around data. What this will eventually become is a single method called perform, which will take no arguments, and that is what will be run. So that's what this is going to become. But because these are singletons, so how the model works currently is operations declare what sockets they have. So let's see. So operations, this operation says I've got 3 input sockets and 1 output socket. This one says I've got 3 input and 1 output, 2 input, 1 output. And how that's done is through create input sockets and create output sockets. So these are both methods that operation is guaranteed to provide. And what that does is it creates new instances of input socket so whenever that's called, new instances of input sockets are created and new instances of output sockets are created. This is again something we were hoping to change, but it's how it is right now. And what that does is that the inputs. So when you create so this is every time you create a step, these are called. Actually, I kind of abstracted out into this create sockets method, and what this does is it calls create input sockets and create output sockets in order to do some weird thing that I'll get into later because it's not as important. But functionally, every time a new step is created, so every time, I need to move this so that I can have it right there. So every time this is creating new step, which then calls that create, which is constructing those new objects. So that's that. Also, there's the icon, the category, the description, the name. So that's what provides the name, all that stuff. That's actually getting it abstracted out into another object, hopefully. So let's actually look at one of these. So blur operation is a good one. So there's the 4 different types of blurring that you could do. So we're looking at this object right here, where you have 4 different types. So this is an enum. Let's see. So that defines the name, the description that you can see here, this description here, and icon. So create input sockets. So what this does is it creates the input sockets, the objects, and because the event bus is a dependency of the input sockets, it has to get passed into this argument. That's one of the abstractions we're trying to decouple. So there's a couple of different thoughts that are bouncing around, and then there's output sockets, and so that creates the output socket. So those are called every time steps created, and then because the operation is a singleton, they can't hold instance variables. This is the major reason we want to refactor it, so that each step has its own operation, is so that the operation can hold references to its own data, so that you don't have to do this next step, which is, so every time the pipeline runs a sweep, perform is called. And what perform does is it passes the input sockets and output sockets that were created and up here back into the object to let it do whatever it wants to do with those objects. So so that's why what we're trying to do by doing this refactor is we're trying to remove this, which is this giant amount of casting that is required to get the data that you already know that you have out of the object. So up here we have an input type of an input socket, which is a mat. We have an input socket, which is of a type, and we have a number. How it knows that it's these types is another layer of indirection, which is this type socket hint. So sockets hold socket hints. See if I have UML for this. So operations have socket hints. This layer of indirection, let's see if I have a better one. Okay. So currently, this is a bit of a mix of what we know. Okay. So currently we have operation. No. Yeah, operation. And then we have socket hint. And we have socket. So there's 2 types of socket. There's an input socket and an output socket. And sockets sockets have socket hints. And the socket hint is what defines the type that the socket holds. So this is when we actually come to dealing with actual classes. So the socket hint is of the type. So under the hood, let's see, socket. I want socket hint. Okay. So we have this builder. This is how you build a socket hint. And you actually pass it the type because we actually are using, underlying all this data is an actual type. So you have like the mats, which are images. So mat in OpenCV stands for matrix, which holds the image data. You have the identifier, which is the name. Yeah. You have the initial value that it can be. So usually you pass it the 0 argument constructor for that, so that it can create the view, which is what view is this support? So like this, for example, is a list view, right? This is a slider. So the operation needs to convey to the view without directly telling it, hey, I want you to be a slider. Hey, I want you to be a drop down. Hey, I want you to be a spinner. And like, there's a difference between this and this. So you have to be able to convey that information to the UI. And because of our decoupling, the core has no idea about the UI. So you can't directly interact with any of the Java FX objects. So that's this. Domain also tells you the range of values that, so like this is like the lower limit is 0, the upper limit is 255. That's how you define the range on a socket. Okay, so back to blur operation. So the socket hints hold the type of what they are. So we have a bunch of like pre-canned socket hints that are pretty consistent. Like this, if you want to create a mat socket hint, instead of having to write out the builder every time, we're just saying like we just created a pre-canned socket hint for you, and all you have to do is give it the name and what's the other argument? With default. So if you want it to have the default, do you want it to default to having an empty mat in it or not? So that basically says, do you want the under the hood, we're using this type called optional, which is the Java 8 equivalent of null, but with safety. So that's one of the things that I've been using a lot, and we use a lot throughout this entire project, is optional return types. So if it's going to return null, instead of returning null, you'll return optional of nullable. And that'll either return 2 objects. One is optional empty, which when you call get on it, will throw a not found exception as opposed to a null pointer or something along those lines. And it also gives you a lot of helpful things like lambdas, like if present, do this thing. So you can, and it also has .is present, so you can check that prior to actually using it. But it enforces the idea that if the value can be null, you have to explicitly, it forces you or kind of gives you a hint to explicitly check to make sure that it is not null before you actually use it. Yeah. Also, in perform, you're guaranteed to get, perform is guaranteed to be called with all the input values you wanted. So all the input values will have a value in them before perform is called, which is something that we realized when you're dealing with like disconnected things. If things are disconnected, like this is disconnected. Like you don't want to have perform being called without having there be a value here. But as soon as I connect this, like now the thing knows, okay, I'm good. Like now perform is getting called, and that's like once it's disconnected. Yeah. Okay, so then you do the operation. You call the OpenCV code with your data, and you throw exceptions. They have to be runtime exceptions. They can't be a specific type. And then, so you get the value out of the input sockets. You get your output socket, and then you reassign the value to the output socket. So the output socket is how data is. So output sockets connect to input sockets. And you have to call set value in order for the socket to be flagged as dirty, so that it'll propagate to the next output. So, for example, like I have this weird one, this weird operation, which I've been working on. I want to do this one? No. Basically, this is a valve operation that I've added. So we have data flowing through here, and this will pump out values. But if I disable it, like you don't want this, tells the UI that there's a new value or not. And if you don't call set value, then it won't know that there's a new value every time. So basically, you have to call set value. The other thing about the way we've implemented this is images are huge. So you want to reuse the same memory space again and again and again. You don't want to call new mat every time and then fill it with data. What we end up doing in 99% of all cases is your output mat. So a lot of the OpenCV methods have a source, some sort of thing they're doing to it, and then a destination. And what you do is you give it the source, you give the destination image, and that will take the source, run the computation, and then plug it, put all that data into the mat you passed it to, which is good because then what we're doing in this code is the output socket, although it doesn't get reassigned to a new memory address every time, it actually, you just pass it the same memory address again and again, so that the same memory gets reused every time. And that is incredibly important on the Robo Rio because the Robo Rio has like 512 megabits of RAM. And we're still dealing with out-of-memory issues. So you have to keep the memory size low, and the garbage collector can't run a million times. It will run, and it will clean it up, but it'll do this jigsaw pattern. So, I mean, images are huge. You got to make sure that you're reusing the same memory space. Memory management in Java, who would have thought? Anyways, so that's operations. Let's just see if anybody's in the chat. Is this active that? This is weird. Let's just see. Okay. I might have not been sharing that entire beginning bit. Wonderful. Well, if I wasn't sharing it, I am now. Sorry, everybody. Well, we got the audio at least. Okay. So that's operations. What's next? So the next logical thing to do is to cover the steps. So sources are basically have one important method, which is create output socket. The thing about steps, so what we did with operations is because there can be any type of operation and we didn't really know, we wanted to make it so that anybody could add any operation very easily. We also have Python in here, but we have no way of including Python scripts in, importing Python scripts in. So in order to support that wide range of things, operations are are written so that you can define it in the operation and have the UI just figure out how to draw it. Steps are a little bit more funky. We have one base implementation of step, and if you happen to fit that pattern, great. You also have to add the ability to add that step as a button, which means you have to tinker with the UI code as well. But steps are kind of more hard-coded, and there's no kind of abstraction for how to create different types of steps. We only have 3 types right now, an image sort. Actually, we have 3 types. 4 types, kind of. Camera sources function. So there's 2 types of camera source: an webcam, which is your local machine, and an IP camera, which is gets a video stream from the web. Those both under the hood use the same thing, which is a frame grabber, which is something else that this library that we're wrapping OpenCV with has provided. And basically the underlying logic behind that is all the same because it's just a camera source and you're just grabbing frames. We also have 2 image adding, even though it looks like 1. If you click on an image and add it, it will create a socket. It'll create an image. If I select multiple images, however, see if I can find another one that's, sure, let's do that one. It'll create a multi-image. What a multi-image is, wow, that hair. So a multi-image lets you toggle quickly between 2 images. So kind of a hidden layer there, but it was something that was requested because FRC gets a dump of a huge amount of images all at once, and then people want to like create pipelines and try to mess around with grip. And if they can just like create one image with all the images, like they get like 300 images, and they can just click through all of them and make sure their algorithm still works with all of them. That was the kind of functionality we wanted to support. Okay. So steps are interesting. So steps is where dependency injection kind of kicks in. We have a step factory, which is a singleton. So this can get injected wherever you want it. If your class is created with dependency injection, you can get access to this class. So the step factory has one method, create, and it takes an operation. This will hopefully in the future take an operation description, which is another layer of indirection, which is trying to make it code more pretty. And that gets the input sockets, get the output sockets, creates the steps, creates the step, assigns assigns the socket. So the sockets need to know about the steps. So there's a cyclic dependency there, unfortunately. So sockets need to know about the steps that they own, that own them. And so then you basically do this assignment. You set the step to be, you set the step when you call, when the object is constructed, the sockets get assigned what step they are related to. Yeah. Steps have that exception witness. Exception witness is a thing that is what creates these wonderful things. They are witnesses to exceptions, but don't propagate them anywhere. They basically tell the UI. Those just exception witnesses. If there's an exception that's not fatal, like this thing is not working right, they're a way of transferring minor messages to the UI. At least in the steps case, we do the same thing for sockets or for steps. Steps have similar functionality. But this is tied to like a specific button type that has this. This is all like from here over is all one component, which is tied to a exception witness instance, and it listens for events that are fired off by it to respond and show this fun thing. That was a fun thing to write too. And it also shows the stack trace too if you actually get a real exception. Yeah, so let's see if I do I know what I can do. Yeah. So not RGB, but it's a canyon. No, it's not canyon. It's fine contours. That's what it is. So fine contours takes a fine contours takes a what's it called? Yeah, it's a binary image. So that because we're not sure what happened, but something happened, and it's OpenCV's fault, not our fault. we just pass you the stack trace up, and that lets you post it if you want. There's also one is a simple message because there's no stack trace associated. It's just a message. So we have two different ways of handling it. So yeah, also dumps exceptions into the log. We need to run somewhere. Okay. Okay. So steps. Steps have operations. They have input sockets and they have output sockets. I just rewrote them so that they were not returning an array, like a literal object array. They're now returning immutable lists. We are, throughout the entirety of script, using Guava, the Guava library primarily, which has a bunch of collection types, a bunch of features, and the event bus. So, and also a lot of times when you're returning a list, we try to return immutable lists so that like you can't add objects to a list even somewhere that you need to know about when things are added to it. Okay. Run perform if possible. This is what gets called by the pipeline thread every time the step says, or every time the source says, "Hey, I've got an image. Hey, I've got an image." Then the pipeline thread runs all of these methods for all the steps, and this is what determines, like, so for example, input sockets, it checks to make sure that all the values are present before calling it. If they aren't, it flags that exception that you saw here and returns. And then we perform the operation, passing it its respective input sockets, output sockets, and data. If there's an exception, we log the exception and then reset the output sockets. And if all runs smoothly, we clear all exceptions. When the step is removed, we remove the step, and then the operation cleanup method gets called, which is useful for some things. Removing memory, shutting down HTTP servers, et cetera, et cetera, et cetera. Shutting down ROS nodes. So you need to know on this, like if you're the last step removed, like you maybe don't want to have ROS still running. You want to shut it down, clean it up. Let's see. Connections. Connections are a mess of reflection and subscribers. This object really could be rewritten to not use event bus. So the event bus, you guys heard about it? Okay, so the event bus does this weird, wonderful reflection thing where it's not a singleton. That's why we pass this event bus object around all the way through our object graph. So objects that are registered on the event bus, if you have a method, so you do event bus.register, giving it the instance of the object. Now, from then on, anytime you do event bus.post event, every time you post a new event, the event bus will go out and say, hey, what things are looking for this message? And the things that are looking for that message will get called. So if I post a connection added event, basically I do event bus.post new connection added event, pass it a connection, or whatever the connection added event. So event, this is actually like, it's a full object. We have an entire package of events. And it supports inheritance too. So like if you have a subclass and you say, I want anything that is a subclass of this, it'll call that too. So as long as it's annotated subscribe and it takes the event as an argument, you do that functionality. So it's a really, primarily the design principle behind that is that the core can't communicate with the UI. So whenever the core changes, the UI has to know about those changes and update. Like you literally cannot call UI code. It's just not. They're separate projects. that the UI depends upon the core. So these subscribe methods get called every time you post a new connection added event, socket added event, and they are created using dependency injection. So the event bus is injected, connection validator is injected, which is actually an interface for the pipeline, but all we have is one method called can validate, or can connect. And then it does assisted injection, so we have this factory that Juice will automatically create a concrete instance of. And what you do is you do, like, there's a whole config file you can read through, and there's like a bit of, like, it's a Java config file where you like say, when you ask for this object, like use this factory, whatever. So it's very, once you understand it, it can be very straightforward, and you're like, oh, this is really cool. But what we're trying to do is we're trying to, the dependency inversion principle is why dependency injection is like a really easy way of doing this. You could do this with factories that are static. That creates tight coupling with static instance objects and all that. So instead, what you do is you say, I want an event bus, I want a connection validator, Juice give me those things. But here, in input socket, so what calls this is connection converter, socket handle view. Yeah, okay, so this is like when I do this drag connection, this is what creates a new instance of the connection, right? So this is this code here. Now what I've done is I've said connection factory.create, and that has constructed a new instance of the connection, which I then pass so that I can do a connection added event. I'd like to move that into something else, but anyways. What I've done here is I do connection.factory, so then Juice knows about the factory. It has its own concrete implementation that it's managed to create for us. And then it does connection factory. It finds the dependency for us and then injects the connection factory so we can use connection factory.create to construct the connection. Does that make sense? Yeah, so it's a level of indirection, and it makes it so that you're not, basically we don't want connection, whatever's creating the connection, to have to know about the event bus and have to know about all of its dependencies. So that's the dependency inversion principle, is that the things that need to construct these new objects don't want to have to know about their respective dependencies. Because then you end up just passing around these weird objects that you don't really need to know about, but your dependency needs to know about, or the thing that you construct needs to know about. So that's how connections are made. Connections, operations, sockets. This is actually getting rewritten to do a certain level of abstraction, but sockets basically are what hold the value. So, so there's a base socket class, which is an abstract class, which is a bit large and probably could get refactored. So we're, there's two types of sockets, an input socket and output socket. And in order to embody this in not having, so we didn't have to do like instance of, we still have to do casting, unfortunately. But in order to get inputs and output sockets, like to figure out which one is which, we have this enum called direction, and the socket takes a direction. You're trying to get around instance of. This should have been, there's probably a better way to do this. But the problem with this is that when you're doing these connections, like I can drag from here to here, and I can drag from here to here, and these are just representing, like all these things are just sockets. They just know about sockets. So this thing, like this doesn't know if it's an input socket or an output socket, and this doesn't know if it's connecting to an input or an output socket. So it has to do that casting in order to figure out like which way am I going.
So, like, if you try to,
that won't happen.
okay.
Because we do can connect. We have this in the pipeline, which is this bigger object we haven't got to yet, that runs all the way. Like this represents all this. That has a can connect method, which basically does a bunch of checks, including making sure that one step isn't behind the other. So like I can't connect this way. Like this output can't feed back into this input. Then what else? So that's that. It also returns, sockets also hold the socket hint. So that's, they actually like, they know about what type, that's how they know. You guys know about type erasure? You heard about type erasure? Okay. Generics don't exist at runtime. So I can't get, like, I can figure out what type I am. Like I can say, what, give me dot get, or like, if you call get class inside of an object, it'll tell you what class it is. But there's no way of figuring out the generic arguments of an object without doing some other weird stuff. But basically, if I don't do this other weird stuff every time I create these objects, you can't figure out what this type is, what type T is, because it's removed at runtime. So that's why you have to, like, instead of just being able to say, like, this is a socket of type, like, something, and having it say, oh, great, I'm that, and, like, if you ever need to know my type, I'll pull that out of that. You kind of have to pass it the like, mat.class or list.class as the type so that it can keep that around for at runtime. Yeah, type erasure is a bit of a pain in the ass, but so type erasure types are there at compile time, just not at runtime. So this actually just turns into like any, like the generic types, just they're gone at runtime. That's why when you try to cast to a generic type, it'll give you a warning about, hey, this is an untyped check or an unchecked type, unchecked cast, because the compiler or the runtime won't even be able to do that cast, because. And the only time you'll know if it's not that type is when you call the method, because then it'll blow up and say, "Hey, I'm like not that object. I don't have that method." Anyways, so I'm gonna shut you down. That's weird. Okay, so sockets, you can add connections to sockets, and you can remove a connection from a socket. There's a bunch of eventbus.post stuff that happens in order to get that information to the UI and other objects. One of the things that I'd like to do before this MQP is over is I'd like to kind of decouple the core from requiring the event bus, because I'd rather have direct method calls because it's more explicit and makes more sense, and it kind of is easier to follow, and have the UI be responding to the core, but the core using direct method calls to kind of interact with each other. But currently we have a lot of code that the core model uses the event bus to communicate with itself when it really could just call methods because it has a reference to that object anyways. But it's one good thing about it is that if you have a on this side of your object graph and you have an object on this other side of your object graph, if they need to communicate and you don't really have any way of getting them there, they can just send messages to each other. But then again, if you're doing this, you might have bad design. So that's sockets. Then we have two versions of sockets. We have input sockets and we have output sockets. And those input sockets and output sockets have a couple more methods. Like let's see, output sockets, you can preview them. So that's what this is. They can be previewed or not, and that's how they hold that information. And we have the link socket hint, which is a new thing that I came up with. This is actually getting refactored a little bit to be different, to use the decorator pattern instead of using object inheritance, because currently I'm just overriding an anonymous version of the input socket and the output socket to add functionality, and I'd like to move that now uses the decorator pattern in a different branch. But what that does is adds this fun functionality that I can do this switch type. And if I add another image here, I preview this, that's frozen. I can preview that, that's frozen. So I connect this and I connect this, right? I can switch between these two types, but they're generic types. So if I disconnect this and I connect a number, like this won't connect, but if I disconnect this and I connect a number, it can connect. So so this is figuring out by after it's connected, what type am I, and then saying these are not compatible anymore, which is not something we've been able to support, but it was something that I was able to support using the decorator pattern, basically, which is cool. So that's how that works, and that's basically one socket hint is tied to multiple input and output sockets. And what that lets you do is that lets you, because the input and output sockets are then tied together, per se, by one socket hint, the socket hint can delegate and say, no, this type is not supported anymore because I now know my type. And then when it's disconnected, there's also this other fun thing that I was able to do with where when you disconnect a switch, when you disconnect, let's see if I do info, get mad info, connect this. If I connect this, this knows its type as an output, but if I disconnect both of these things, the type's no longer known, so that thing disconnects the output. Yeah. Let's see. That's sockets. The pipeline. No, let's do the palette first. Palette is this giant, it's basically a map with the name of the operation to the operation that it is. And this is important for deserialization because all we know in the file is what operation name is this. And we also, as we've gone on, we've figured out, hey, there's aliases. Like, so, for example, like if I change the name of the operation, like I still need to keep compatibility with old saves. So like we've created this idea of an alias. So an operation also has an alias. And so we also map the alias to the operation so that if you happen to have an old save with an old name, it'll be able to look it up and find it. Yeah, so that's that. Also, operations have to be uniquely named. So if they're not uniquely named, we don't know which one you're looking for in this save file. So no overriding operations using the same name with different functionality. I'm taking programming languages, and the more and more I've worked with them, I'm like realizing we've kind of implemented a language in a construct of Java. So that's that. Pipeline is this huge mess. So the pipeline has a couple issues, but here's what it is. Pipeline contains sources, it contains steps, and it contains connections. It's kind of our God object, but we're trying not to have it be. It's the entry point of all the logic. And it's the basis of the serialization and deserialization. So all of our serialization and deserialization runs through this thing called Xstream, which creates XML files for us. So it deserializes the XML and reads index as XML. So the pipeline has a list of sources, a list of steps, and a list of connections. And so you can get the steps that are currently, and what that does is it actually creates a immutable copy of the list, and so you basically get a snapshot of the steps, because the step list could change at any point. Like another step could be added, another step could be removed, especially if you like clear the pipeline. Get connections. Those are not. We don't have thread safety issues around connections. The project settings are here. They really shouldn't be here, but they are here. And since it's the root of deserialization and reserialization, can't really move it without having to write something else to handle that, which I haven't had time for, and I'd like to do at some point. But right now, the project settings live in the pipeline, which also breaks the principle of single responsibility. Okay, so this is the can connect method. This is what determines if a connection can connect or not. You actually know the type at this point because the pipeline implements connection validator, which does that can connect when you don't know the type for you. So if you call can connect and you don't know the types, it will call can connect with the types actually resolved. Yes. Pipeline. Okay, cool. Connection validator is before. That's pretty, like, just make sure that like one's not before the other. So we have two different ways of adding steps, or sorry, we have two different ways of adding things to the pipeline. And this is another one of those like inconsistencies that like we half implemented it over here and didn't quite fix it over there. You can add steps using direct method call. So you can tell it, I want to add a step at this index. I want to add a step just to the end of the list. I want to remove a step, and I want to move a step. You can do any of that. In order to add sources, you have to emit an event saying a new step, or so the pipeline listens for source added events and source removed events. That should only be refactored into direct method calls where the pipeline does the event emission, which is probably wouldn't take me that long. I haven't had time. And connections are similar, where you call connection added and connection removed event. Also, project settings changed events. So the pipeline holds the project settings. That should really be the other way around, where you call on some other object, probably a project object. Say that 10 times fast. So we'll probably have a project object at some point that has the project settings, and then you call set project settings, and that would then emit the event of all the stuff has been updated. Let's see. I've also added some methods. You'll notice, first thing everybody tries to do, drag and drop doesn't work. I added that in the new pull request. So the drag and drop actually works. I added the functions add step between, which takes a step to add, and then two steps that you know are on either side of it, and it puts it in the middle of them. So all the logic is in the pipeline, so I can test the pipeline and make sure the pipeline did what I expected when I passed it different things. So that's in there as well. Yeah. Okay. The pipeline runner is another object. It's actually, so Google has this thing called a service. And service has a couple states. It has, look down the tree, service. Service has a state. It's got new, starting, running, stopped, and terminated. Those states are representative of different, like the life cycle of a thread. So they basically have taken the life cycle of a thread and have said, these are the different states you can be in. What we've done, I've broken the contract. This is before I took the WAD. I'm probably going to refactor this to change this. But restartable service, so the guarantee of service is that there will be a logical flow of new to starting to start to running to terminated or stopped, depending upon one. And after you're in these terminal states, it'll never return to the original state. And I said, I need these things to be able to restart. So I wrote a way to take a service supplier, basically you pass it the constructor for a service, like not new something, but you say like this is how you create a new service, and it'll, when it shuts down, you have the ability to call start again, and that will then call the constructor again and call start. So like if my service and the other case is if the service thread throws an exception and dies, you might want to have it restart automatically because you want it to like kick over like an engine and restart. So that's what the restartable service is for. Pipeline runner is a restartable service. And what it does is, this is actually, so restartable service is an interface. It uses composition instead of inheritance. So there is a restartable like an abstract restartable service that you can use, and that's where you define like the thread logic in that. But what this thing does is it this is how I stop and start the pipeline. This is basically what I'm doing here. I'm stopping and starting the service right there, so that like if I don't want to have my CPU being spun up and running all the time, like I want to be able to like do a couple of things, change some things in the pipeline, maybe walk away from grip and not have it running my fan or whatever, we can hit the stop button down here. Also, network tables. If you deploy to the Roborio and you also have this running on your computer, they'll both be sending the same messages. Similarly, if like you were to deploy to something that was using ROS, you'd have two programs trying to post to the same topic, and it would just kind of get flooded. And like if you have like a camera on here and a camera on there, it'd be getting two different pieces of data at the same time. So when you deploy, this automatically stops the pipeline. So you have to restart the pipe. You have to hit start on the pipeline again, which I should probably make this like bright and green and glowing to make you like know that, hey, we've stopped. Okay. So this just has like, so the thing about this has like start, and start and await. Like for testing, you usually want to use start and await to make sure like the thing has started. But like most of the time, you just want to like start async and just like let it go. And when you call start async on a service, it just, like you said, I want you to start and go away from it, and that'll just let you continue to run your whatever code as opposed to hanging on waiting for that thing to start up, because threads can sometimes take some time to start up. Also, shutting down, you don't want to have to wait on a thread to shut down. So you just say stop async, and that will just, yeah. All right, this is run pipeline. It's visible for testing. It's not private, not public. It's just package private, so you can call it. And this thing is what grabs the sources, grabs the steps, and then basically, as long as we're still running, updates the output sockets. So this is where that whole thing that I said originally about sources saying, hey, I've got a new value, I've got a new value. This is where you actually do the logic of, hey, I've got a new value, hey, I've got a new value. Okay, give me that new value and please put it in an output socket. And that was done because of threading and having issues of race conditions where, because sources are constantly putting cameras are grabbing data and putting an image, grabbing data, putting an image. Every time you call grab, that's overwriting the old image, but it's putting it in the same memory space. So you could have, like, if we were trying to use this image and process it in another thread, we would have the camera source putting data of a new image into it while this other thread is actually processing that camera. So what we have is we have one image in like as a buffer that is this image source. We have one that is like a middleman that is has synchronization locks on it. That makes it so that the other thread, this pipeline thread, basically, so the camera source thread puts the data into this temporary thread. The temporary thread, then it tells the pipeline, hey, I've got an update. The pipeline thread then grabs the lock on this this camera source thread and stores the value in the output socket so that it can be used in the pipeline. Anyways, that's that. And then we iterate over the steps and call run perform if possible. And what run perform if possible is tries to run perform on the operation. If it can't, it does that little blinky light. Some other weird functionality, weird things. Oh yeah, so you'll notice that we have something like an ungodly number of operations, especially in OpenCV. I didn't write all these by hand. I wrote a generator to do this because we have like a template of this is what an operation looks like. This is, so we have that interface, and as long as we could get something to conform to that interface, like there's a lot of operations in OpenCV, like the add operation, the flip operation, that all like have this common like method structure where you have mat source, takes some number, and then a destination. And I'm like, I'm gonna end up writing the same thing over and over and over again, or I can generate that. In hindsight, I probably could have figured out a better way to do it, and probably will figure out a better way to do it because we're rewriting the operation anyways. But at present, we have a build. We have a build thing here, build SOC, that I can't, for the life of me, get to figure out that it's actually source code. Mark directory as sources root. Mark directory as sources root. Mark directory as, so this will at least render correctly. So what this is a build step. We don't dynamically generate operations at runtime because that would take, I don't even know. I actually thought about having to do reflection with this, but there are better ways. So the entry point is groovy because that's just how that's just how Gradle works for that. Once I realized, hey, Groovy talks to Java, I basically wrote a very, very minimal amount of Groovy code and then immediately enter Java world. And this is all, the whole generator is written in Java using a library called Java Parser, which does two cool things. It takes a source file and then converts the entire source file into an abstract source tree that lets you like navigate it using objects. So like I can visit all of the objects. And so that is how we end up with all of these and all of these and all of these enumerations that we only use some of, and all of these enumerations that we use all some of. But some of these enumerations are very large. And the reason we use these enums like this is because this is how the library defines enums. Public, static, final, int. And I can't get an enum value out of that. So if I want to have a UI dropdown for that list, I either have to write an enum by hand or I can have a generator kick me out an enum. So that'll probably stay. We will probably never rip out the enum generator because if you ever want any of these enums and you don't want to have to write, there's a good one. There's some ungodly long one that I've seen. I don't know. So there's some one like I don't want to write this by hand. This is all dynamically generated at compile time. Compile time. So we generate something like 50 some odd operations, and they basically just say like this. So basically, it looks at the method that we want to call, which is flip, and generates all of this code around flip. So flip, it looks at, says, hey, you take a mat as a source, a mat as a destination, and a flip code. And we do some mapping of like flip code to like actually being an enum, I think, yeah. flip code is mapped to, and yeah, flip code is mapped to the enum of flip code. Cool. So so that's how that works. So basically, like, we do some like looking at, because it's parsing the syntax and can say, hey, like this parameter is an SRC, and that, like, there's a lot of methods in OpenCV that follow this pattern of SRC is the source, and DST is the destination. So we just infer that if it's a source, that's an input socket. It's a destination, so it's an output socket, and anything else is going to be an input side, going on the input side. You can actually override that functionality. So basically what you do is you say, in this file here that won't actually render as correct Java, unfortunately, you say, I want threshold, I want a mat, double, int. Like this is the signature of it, and then set the literal default to be thresh binary. Like you can, this is my structure, not the library structure. And then you can add descriptions like that. This may get rewritten, not 100% sure. May get tossed out a window if we figure out a better way between now and the end of the year. But this is what it is right now. Oh, you can also say like set default with value and then object default value, size, and then pass it these two arguments. Yeah. So you list out the functions you want to support, and this thing finds them and then maps them to operations. And so you don't have to write all the bullshit like boilerplate code for all of them. Yeah. So that's the parser. The UI, how much do I need to go into the UI? The UI is JavaFX under the hood. So what we've done for JavaFX is, so we use dependency injection pretty much everywhere. Anything that's dependency injected automatically is registered on the event bus. So if your object uses dependency injection, your object also can do subscribe, or what we were originally doing, and we realized this is a really bad design, and I've done some I did some chatting with the Google dev, the people that wrote this in their mail room, is in the constructor we were doing eventBus.register. And what that does is that exposes the object to other threads to have its methods called before the constructor is completely called. Does that make sense?
I'm very distracted.
Okay, it's okay. One thing that I figured out in this project is you think you understand Java, and then you really don't. For example, if you pass a reference to this variable of an object outside of its scope, you can have variables that should be final and not null be null because something calls that. Does that make sense? So if I pass my reference, like if at the top of the constructor, I pass the reference to, and then I do my assignment of all my final variables below it, anything that has the reference to me before these variables are set can call back and have no pointers happen. This is because even though the object is not technically fully constructed by the time the constructor is called, you can still pass a reference to it outside of itself, which is pretty problematic when you have a multi-threaded environment, because those other threads might try to access variables and, hey, I'm null, even though it's a final field that shouldn't be. So that's what we were dealing with the event bus. You realized, hey, what happens? What if we just, like, how do we fix this problem? And the best thing we came up with was, well, we could do all this like weird, wacky stuff where we like have an interface that says is the event bus, whatever. So we're like, this is ridiculous. What other methods And dependency injection, you can basically say on every object that is dependency injected, after the constructor is called, event bus.register. So if you're using dependency injection on your object, you get the event bus for free. And it doesn't create any problems with memory. The only thing that can be a problem is that if you're done with the object, you need to remember to event bus.deregister or remove or whatever, because otherwise you'll have like memory buildup. But the convenient thing is that if you don't have any methods that are subscribed to in that object, the event bus.register does nothing. So because you don't, like, methods can't be dynamically generated at runtime. So unlike JavaScript, so that's that. Yeah. Is there anybody here? No, 0 viewers. Okay, cool. Let's check this over here. Okay, cool. Yeah. So components. So UI components. We have for all the input sockets, for each one of these input values, they like each have their own class. So you guys done anything with JavaFX? Okay, JavaFX. Nothing with Swing. Okay. So with Swing, all of your UI is defined in objects. With JavaFX, all of your UI is defined in FXML. So if I go to resources and I go to, this is our main window, and it is all laid out in FXML. It supports CSS, supports JavaScript to some extent, apparently. I haven't messed with any of the JavaScript. But it lets you use Scene Builder, which is this other UI component, which lets you design scenes and design layouts and stuff like that without writing any Java code. And then if you like ever want, then like you can have your Java code like controller modified all you want. But if you ever want to like go back and redesign your UI, you just pull the FXML into Scene Builder and just reconfigure your UI a bit. Really, really convenient, and totally decouples your UI from your controller. So you have the model view controller, and the core is technically our model. The view is the FXML, and the controller is, well, it is actually that's not what I want to do. You can actually click on it and main window controller. What actually happens behind the scenes is when you create the main window, you actually use, so in our main file, dependency injection setup, stuff like that, create injectors, inject members, blah, blah, blah. fxml.load main.class.getResource main window.fxml. So that loads this main window FXML file and uses the injector to get the instance of the class. So like that ties the dependency injection stuff to the juice into the FXML loader. So that makes it so that Juice can become aware of, so you can inject, JavaFX constructors are a pain in the ass. That's the fundamental point of this. Constructors are a pain in the ass of JavaFX. So using dependency injection makes it a shit ton easier. So I can load. So basically what it's doing is it's saying, create a main window, and whenever you need to load a new instance, use dependency injection to get it. So that then creates this. These are all, this is field injection. Not a huge fan of it, but it really works for UI. Then FXML does its own field injection, and that assigns these fields to be So let's, ooh, that's not what I want to do. So for example, like this knows that it's has a respective object. So if I click this, it'll map it directly to the FX ID. And these are now like the same object, and I can do everything that I want to on this Java object as is in this main window. So, and also, if you in a controller, if you want to do any instantiation code, if you put a method called initialize in the controller, it'll get called by JavaFX automatically. So that's all this, and so all this stuff is so all this stuff is JavaFX all the way down. So I don't have any good examples of anything from here on out. These are all the previews. Like this is how we do the previewing of all these things up here. So the only other complicated thing about this is that there's some things that like you need to have JavaFX. You need to have a constructor because you need to pass arguments. So what we've done for that is, let's see, this is a good example. Yes, okay. So the input socket controller, so the input socket controller, this is what renders these things. This is like this whole component here. And that, so this component right here, that needs to use dependency injection in order to be created. So what this does is we have an input socket controller, which because you need to take an input socket to create the controller for it. So what we've done is we added this annotation called the parameterized controller, and basically what we've said is this controller maps to the input sockets.fxml file, and when Juice is doing its dependency injection stuff, we add another rule that if you find this annotation on a class, go find that resource and make it a controller. So it like basically this. I look at this. I think it's used here. Yeah. So if this annotation is present, then load. Do a load. Grab the annotation's URL and pass it itself. So that is what allows us to get these fields filled in, which is like the root, the identifier, and the label. And that's how, so that we can take this as a constructor, what it is actually representing. There's a lot of code here. A large project. The infrastructure is generally pretty solid. It works with testers. What else? On the other end of things, for Git setup, we have a bunch of integrations. These are kind of fun. This is the, like not so much code stuff, and this is kind of the world that I ended up working. I do a lot of code, but I also have fun with these things. So we use Gitter for code coverage, gives our code coverage. Codacity does code reviews, and AppFair does Windows builds automatically for testing. And Travis does builds automatically for, so basically, whenever I open a pull request, I see I added the drag and drop operations here. First thing that happens is Travis runs it, and AppFair runs it. So Travis runs it on a Linux machine on their servers, way out there. We don't care about them. It's great. We provide it for free to open source projects, so you don't have to pay a dime. AppFair grabs it, runs it on Windows. AppFair is significantly slower than Travis, so we don't usually require it. We actually only have one required check. You have to have Travis pass to merge. you can override it, but like it will scream at you a little bit, and it'll make it painful for you to have to merge it without having Travis pass first. So it really makes it impossible to write master. Also, you can't push to master, and you can't force push to master, so you can't break master without having it go through a pull request, which is good. It also enforces the idea of like, we want to do code reviews. So like Tom and I would always code review, which is a really good practice to get into. And then Codacity does its thing. It runs PMD and a couple of other static code analysis things, and puts a pass-fail as well as it comments in line. It says, like, this is a check that failed. You should fix this. Like doing throw and then, or like doing new runtime exception without having a throws before it. Like you can write that in Java, but probably meant to put throws new something, not just new this and let it, yeah. We have code coverage. You can look at the coverage like live in here. This is something that when Travis runs, it runs the tests with Jacoco. And then there's a nice little plugin that they've come up with that basically forwards all these test results to CodeCov, and CodeCov will nicely display all of your code coverage for you. So we know what it is. It's rather low, kind of upsetting. Mostly it's UI. I think we've got like 86% coverage on the core. But UI tests are not actually that hard to write. I should run these. These are actually pretty fun. I'm actually gonna do this. Git checkout, feed drag and drop operations, and then I can do drag, W, check, clean check. It's kind of fun. So this will run all of our tests right on your machine. Actually, looking into, I'm bouncing through my head. I have these grand ideas, and like a lot of them will get shelved, but like there's just like really, JUnit 5 is about to come out, and that has some really cool testing features like multiple exception catching, and I'd like to see how, apparently it wouldn't be very difficult to port Java, all of our stuff is JUnit 4, and porting it over to JUnit 5. Yeah. Oh, okay, brief overview of the build system. So behind the scenes, when we're building, this is the UI test. It actually runs through all these things, and oh, this is over. So we built a jar with a core in it, and we one second. All right, cool. I'm just gonna shut this off. How do I shut this off? Close tab. Okay, cool. So we have, so we build a jar which has all the core stuff in it and all the core dependencies in it, and that's what gets shipped over to the robot. And the UI kind of has a bunch of other dependencies. So what we end up creating is this Uber jar that has a bunch of other jars inside of it, and that's what gets sent over there. And this is kind of like a weird build setup, so it's not really what Gradle was totally expecting, but Gradle's awesome. You can configure it however you want. So it's managed to figure that out. And so that, we create this jar, send that over, and that means that you don't have to send 2 versions of grip with every thing you want to upload. Actually, yeah. So Travis runs the UI tests and the core tests every time we want to do anything. And so why is this frozen? Okay, cool. You have any questions? I've yammered on for, how long have I yammered on for? I don't even know. Yeah. You have any questions? Are you interested still? Actually, we should probably kill it. All right, so that's the explanation. I know we ended up with 0 viewers, so that's the entire thing. Yeah, so this should end up on my Facebook, on my YouTube channel. Cool.